So good afternoon once again. No? So last meeting, I've given you an assignment to do, and you have a long time to do that. No, so it's due today, 1 o'clock. You're supposed to do. I'm not going to answer everything. No, I'm just going to answer the looping part. Okay, because I believe the rest is very self-explanatory, so that we can proceed with our next few lessons. No? Okay, so we have a looping program already now because we have a problem with our loop, no? Because there's a problem with incompatibility between CF and jump plus. So we have here the IAS loop factorial, no? Okay. So the significant part of the program is the looping part, no? Okay, so how can we make a program to compute the sum of the first three numbers? You can just copy this, right? And then we will change the multiply to it's the same logic, the multiply to plus, because the main difference between factorial, the main difference between factorial and sum is multiplication and addition. Okay, let me just erase this. Sum, no? Sum of the first n numbers with summation. Okay. Three numbers, no? So we'll have it here as 3. Okay. So remember that our partial product, this is no longer our partial product, but our partial sum. Okay. And then this will be our next addend. We follow? No? So if you've gone through the exercise, it must have been easy. Okay. Ito lang naman. The main reason why I'm doing this because we'll be doing another last machine. It's the PDP-1. In fact, there's an assignment there already. No? And the main point why I'm giving you that because I'd like to illustrate a change that was done later, no, in the next, because PDP-1 is a derivative, no, it's a derivative of the IAS. It's a late derivative, but it has a lot of improvements that made programming a lot easier, no, on a stored program concept. It's a late derivative because the PDP-1 came in 1959. This came in what, 1952? Do you follow, no? Diba? The IAS came in 1952. Okay. 409. Load M1. So this becomes, we are going to have 3, no? So the sum of the first 3 numbers. I'm just going to erase this anyway, no? We may not have all the past. This is the loop, no? With loop. Sum of the first 3 numbers with loop. Okay. Let me just erase the whole code. We have our tail here. This is a top-down loop, right? Kasi that's the most appropriate approach if you have a jump plus, no? Okay. So, instead of an M here, we will have a plus. Okay. Instead of a mul, we will have an add. Let me check that out, no? Very easy, no? They follow? Okay. So load M1, negative M1. So this will become negative 3. Okay. Add M2. By the way, let's write down the values, no? This is we remove this. So M1 is currently what? 3. The M2 is 1. Okay. Add M2. So the actual content will be negative 3 plus first 3 numbers lang tayo, no? Let us not be confused, no? Now let me Put that, no? 3 minus 1, no? That should be negative 3 minus 1, okay? You follow? Negative 3 plus 1, I'm sorry, because we are doing an add instead of a minus, okay? This is the same program which I've explained to you last meeting, no? So there's no reason why it will be difficult. I've changed the mole to add, okay? You follow? So 3 plus 1, so this becomes 2, okay? And store M3, so this becomes our, this is a 3, okay? This is our next addend, remember? Okay? Okay. May mali tayo konti, no? Sorry, no? Padali, no? Because we had add M2. This will be 2. It's a jump plus, no? So we will not jump, we'll go here. Load M3, add M1. Okay. No. May mali tayo, no? Okay. Because this should be a 2, so this should be a 2. Okay. They follow? They follow, everyone? Because we had add M2, this 2 minus 1, store M3, so this becomes a 2. Do you follow? It's not a 3. I made a mistake there, okay? Let's shorten this so that it doesn't move. Do you follow, anyone? Any questions? Wala, no? So anyway. Limutan ko yung aking mukha. Anyway. So we are going to store 2 here. Do we jump plus? Yes, because this is a plus. So, ano? Sandali. This should be a negative 2. I'm sorry, no? I'm wrong again, no? They follow. Negative 3 plus 1 is negative 2. I'm sorry, no? This is a negative 2. Because we are supposed to jump plus. So do we jump plus? This is not this is a negative value, so we will not jump plus. We will proceed here. Do you follow? Do you follow? Yeah, thank you, no? Mr. Yap, it's negative 2. I'm sorry. It's good to look at the chat, no? Okay. Load M3, which is the absolute of M3. So the absolute value of M3 is 2. So we'll put it here. And then add M1. So we will have 2 plus 3. Okay. So 2 plus 3 is 5. They follow. And we store M1. So this is our partial sum. This becomes a 5. Okay. Any questions? And then we load M3. So this is a negative 2. Okay. Add M2. So this is a negative 2 plus 1. So negative 2 plus 1 is a negative 1. Okay. And then there's no condition. So therefore we will go back to the left. Okay. We'll go back up. We'll just copy the code itself, no? And this will be our second pass. So it works perfectly, no? So nothing new, no? Store M3. So this is negative 1. We are going to store it to M3. This is now negative 1. Okay. Jump plus. This is the accumulator. We'll put it here so we don't get confused. This is our 5. This is our 1. This is our negative 2. Okay. These are the previous values. Okay. Okay. We store. So the negative 1 we store to M3. It goes back. It goes here. And then jump plus, it's a negative, so we will not jump plus. Load M3, okay? Load M3, so this is the absolute of M3, so you have 1. Now, if you don't have an absolute in your instruction set, you can just easily multiply by negative 1, okay? Because later we will have another computer which doesn't have an absolute, no? So add M1, so this is sorry, this is negative 1. Negative 1. Okay, so this is negative 1 plus 1. We follow? Okay. Sorry. Load positive of M3. This absolute load absolute. So this is 1, no? And then we have add M1 now is 5, okay? If I'm getting lost here now, I'm sorry for that. 5 plus 1. Okay, 5 plus 1, this becomes 6. And store M1, this becomes 6. Okay, and then we load M3. M3 now is -1. Okay, -1. This is not the absolute value. We have add M2, so we have -1 plus 1 plus 1. So this is now a 0. So we are now going to jump again to the beginning. So this is our third pass. Okay, third pass. Okay, this may be our last pass. No, so we'll just delete whatever things. This is pass number 3. Okay, do you follow? So store, this is what's the value of our accumulator. This is 0. This is 6. This is 1. What's the previous value of this? This is a -1. Okay. So we store M3, so this becomes a 0. And we do a jump plus 9, so we go to 9 right away. We'll go to the tail. We'll delete this. Okay. Do you follow? Okay. Any questions so far? I'll save this now. And then upload this to our website. No, I'll upload this because yeah, today is the deadline, and the others cannot submit it anymore. Okay. So where do we go? ADD. So this is a problem with the new IAS sum and average. You follow? Okay. How do you compute the average? The problem with this here is we lost our Do you follow? We have lost our divisor because this is initially a 3, nagiging 5, nagiging 6, and it became 6. And obviously we cannot divide it with 3 anymore. Do you follow? So let me just copy this. This will be average. Anyway, we'll just copy this. No? Pareho lang naman sila yan. To make a long story short, I'll just copy the whole code. What's the difference here? Can you see that already? So you just have to adjust the lines, okay? I-adjust lang natin yung lines, okay? Because we will have an M4. Okay? And then, yeah. And then we will insert. This will be our 4L. Okay? Do you follow? Okay. So 4L, 5L, no? So we'll say load M1. Because we're going to save the and then this will be our 5R. 4R. Store M4. You follow? So yeah, we'll have to change this. 5R, 5L, 6R, 6L. Okay, and then we'll have 6L baligtad, no? This is 5L, 5R, 6L, 6R, 7L, 7R, 8L, 8R, then this is 9L, okay, 9R, this will be 10L. I will just delete the others. Hindi pa to halt, no? This is not yet a halt. A halt will be different. We'll just trace this quickly, no? So anyway, we jump 4 to 19, and then our jump class will be 10L. Okay. Do you follow, everyone? Please ask a question if you have a question. In 10L, what will we do? Okay. In 10L, we will divide our sum. No? We are going, our sum is in M1. Okay, we say load M1 in 10R. Okay, we say div. There's a div, no? Div M of 4. They follow. This is the average now, right? So that's the main reason why we have our 11L. We had our value saved, no, to M4 so that we can retrieve it later. Kasi this will become so AC here will become 3 and M4 will become 3. Okay, they follow. They follow. We'll just trace this anyway, no? It's the same, no? So anyway, so this will be our jump. 11, 0 to 19. This will. Did you get this, guys?
Yes, sir.
Okay, so halos pareha lang. Do I need to trace this? Halos pareha, they're the same, right? So what we did was we add a load M1 because this will be our store. This will not the accumulator has changed because we have loaded M3. Okay, and M1, remember, is our M3 is M1 is our partial sum. So our partial sum, we load it again to the accumulator. We divide by M4. Okay. Any questions? I will upload this. Okay. Umiktin is late. Umiktin. Okay. Any questions? So I'll save this now and then upload this after the class, no, for your reference. The other program is very easy, no? Fahrenheit, C to F. It's very easy. Save. Okay. Any questions so far? Now, before we go back to our main lesson, I'd like to show you, no? I'd like to show you another program, another computer. No? This is called the PDP-1. Okay? The PDP-1, kasi ganito yan. Let us go through the chronology. Itong nangyari. Let us look at. Can you open that, no? The chronology of computers. Since 1952. Okay? 1952 was the invention of the IAS, right? Now, this is a chronology of store program computers. During those times, no, there are two big manufacturers, competing manufacturers, IBM and DEC. IBM is International Business Machines. This is from Hollerith, no? And DEC is Digital Equipments Corporation, yung kay bagong Gordon Bell, but it has started differently, no? Okay. In 1952, the IAS was completed, and EDVAC was also completed. Okay. But this EDVAC is a product of Presper Eckert and John Mockley. There's a big story here, no? We'll tell that story again. And earlier in 1951, there's a debate who came first, no? UNIVAC 1, which was also a store program computer, was released by Eckert and Mockley. Now, Eckert and Mockley later became Remington Rand and Sperry Rand later, no? Remington Rand, and then I think they become IAS became Honeywell, no? Yung si John Van Neumann. I don't have a source for that. I tried to look up, no? So ito yun. 1952 was the completion of the Prince of the IAS. And remember that it was first conceived by John Van Neumann in 1946. Okay? Do you follow? So in 1953, IBM, who was also working with Remington Rand at that time, affiliated with Remington Rand because they're selling, no? They're selling machines, no? IBM, remember, was affiliated with Harvard, no? Created their look alike, no? Created a clone. You may ask, pwede pala yun? Can we create a clone during those times? There's a story behind this. No? IBM 701, no? They call it the EDP machine. Do you follow? There's another jargon there. EDP, no? That was first coined in the IBM 701, Electronic Data Processing Machine. Do you follow? In the IBM 701. It's a 36-bit data and 18-bit instructions, so very close, no? Very close to the IAS. Remember, the IAS is 40-bit data and 20-bit, no? 20-bit instructions. So it just moved a little, no? Instead of 40 bits, it's a copy and paste. For me, it's a copy and paste because they just reduce the 40 to 36 and the 20 to 18, which means that there's also a left and right, no, instructions. So remember that the IAS has 8-bit opcodes, no? The 701 has 5-bit opcodes and 12-bit operands. They follow because it's smaller, 18 lang eh. May kulang, no? May kulang sa kanya because it should be 6-bit opcodes plus 12-bit operands. So there's an excess, no? So like the IAS, it has 4096 words in memory. They follow. Also organized according to left and right. It was made of William tubes. These are vacuum tube diodes during the time. However, the main difference is it has 2 accumulators. Okay? Do you follow? And this was built for fixed point siya. It's fixed point, but it was built for scientific applications. Because anyways, 36-bit, so it can handle a lot of values, no? Accuracy. The accuracy is okay because it has 36 bits. During those times, this made IBM rich. Why? Because they built 19 of this. Many of them went to Harvard, and they had it for rent for $12,000 a month. No? Do you follow? Now, IBM dominated the market during the 1950s, but the late 1959, DEC came about. No? What DEC did was, instead of building a very large computer, a computer with a big memory, kasi they just reduce it to 18-bit. Okay, which means that there's no more distinction between left and right, between data and instruction. Do you follow? So data and instruction are the same length. No? Remember, in the IAS, data and instructions have different length. Now, in the PDP-1, data and instructions are of the same length, 18 bits. Do you follow? Okay. So it also has 4K of memory, no? Like the 701, it's fixed point arithmetic. Now it's the DEC computer which has a CRT display. I'm not sure if it's the first, no? But it already has a CRT display. It has a typewriter using a keyboard, and it runs a game called Space War. I'm not sure if this is the first, no? I'm not sure if this is the first machine that runs that game. Okay? We'll look at that, no? It sold 53 of them from 80. Now, the low end is 85,000, the high end is $120,000. That's very expensive during the time. They said it's slow, no? Because IBM was already selling a 13.5 MO to 7 during the time. But since PDP-1 introduced small computers, these are affordable computers that can be bought by small companies in the US and even in the Philippines, no? There's a PDP-8, I think in one of the big schools, no? So this is the main difference, because PDP introduced a uniform memory word, which means data and instructions are of the same length. Do you follow? Which makes it easier to program. Okay, let's look at the programming language. Now, there are many different sources, no? But I'd like to use the handbook, no? The handbook of the PDP-1. The PDP-1 handbook is here. Did you read this material, no? The PDP-1 handbook. So if you look at the instruction set, okay, so the number system is fixed point. There's already indirect addressing, no, which means that you can say load AC, which means that what is loaded to the AC is not low. What is loaded to the AC is not a value from memory, but the value pointed by AC. Anyway, we will discuss this in one of our future sessions. But what's important here is, look at that. It has a program counter. It has an instruction register, memory address register, a memory buffer register, and a single accumulator. Do you follow? Isang accumulator. We are interested in the instruction set. Okay? Do you follow? So it has a sub. It has an add, a sub, exactly the same as the IAS, no? Do you follow? When you say sub Y, okay, the contents of memory Y is subtracted with the contents of the AC. Do you follow? When you say add Y, the new AC, the contents of AC, CAC means the new AC, is the sum of the contents of Y. C of Y is the contents of Y added to the original AC. So AC receives AC plus M of Y. Do you follow? It's more straightforward, no? Now it also has a jump operation. Do you follow? The jump operation. But the problem is the jump to an address. It cannot jump directly to a large address. It has a jump. Oh, it has a jump operation. Can you see that? Okay. It has a jump operation. Okay. Like the jump of the IAS. Do you follow? There's a special jump and save the program counter so that it can call a function and return to the program counter later. Okay. For the moment, we will discard that. No. There's also a jump and deposit. Now, deposit is the store. No. Binago na niya ang store. Ang load is low. No. Load accumulator. Okay. Low means load accumulator. Do you follow? Hindi na load. It has to change. No. I don't know why it changed. There are shift operations, no? And then what I'd like you to do is look at the skip. When you say skip, a skip is like a jump, but this time it will only skip one line. Do you follow? Do you follow? So however, it has a lot of skips. No? Skip on minus. Okay, it has skip on zero, ZZO, and then there's also a skip on zero accumulator. SPA means plus accumulator. If the accumulator is plus, which means it is if the sign bit is zero, no, which means that I think this is the equivalent of jump plus. Okay, but we have a skip on zero accumulator, which is the equivalent of CF. Do you follow? Fortunately, we have an equivalent of both jump plus and CF, which means we don't have to worry about the structure of our loop. We can either have top down or bottom up because we have both. Okay. So skip on zero accumulator. Do you follow? When the accumulator is zero, which means that the equal plus, the program counter will advance one position. Only one position is skipped. Do you follow? Do you get my point? So I think I already have here an example of the factorial program, the same factorial program, no? The same factorial program, okay, but this time it's on the PDP-1. You will solve this, no? You will have an assignment on the PDP-1. It's just the sum and average, no? Sum and average of the average, just the average of the first three numbers with loop. Okay, I'll give you an example because I have an example here. Okay, factorial program with loop on the PDP-1. Do you follow? Now, I'd like to show this to you because obviously this is much simpler, no? And it makes programming a lot easier, no? We can see the improvement. Okay, where's that? PDP-1. Okay, factorial. I may not save. I may not have saved it here, no. So let me just download this. I'd like to discuss this, no. With you because PDP1. Is there a PDP1 here? Hello, hindi ko na save, no. But anyway, this makes programming a lot easier. So remember that PDP1 has an equivalent of a CF, no? Do you follow? Okay. So ito na ngayon. Can you see that, everyone? Can you see the? I'd like you to take a look at this. Now this is the same program. Do you follow? Okay, the same factorial program we have. Okay, do you follow? But this is on the PDP1. Do you get my point? No? So PDP1 na ito ngayon. Now look at, we don't have a left and right anymore. Okay? Why don't we have a left and right? Because our data and instructions are the same. So this is the improvement in the PDP1 computers. Do you follow? Because unlike IBM, it has adjusted, no, the size of its memory word so that data and instruction will have the same length. Unlike in the IBM PC, or not the IBM PC, but the IBM 701 series, no, data is twice bigger than the instruction, which was the practice in the IAS, because yeah, they want to be accurate, so they have 40 bits. But anyway, most common than not, no, computers are not used in very precise operations, so you don't need 40 bits. If you compute payroll, how many decimal many decimal places do you need for payroll? 4 at most, maybe 2. Do you follow? And how much is the biggest payroll amount? What, a million? No. So 18 bits is already enough. Do you get my point? 9 bits for maybe if you have 18, you have 5 binary places. Okay, 18 minus 5, so which will give you 13, and you will have 13 for the integer part, a whole number. That's a very large value already. Do you follow? Considering that it's fixed point, no? So you don't need a very large value. So a very precise value. So DEC made it a point to simplify the whole process by limiting the address, or rather the word size of the computer, of the memory, to that of the instruction. Okay, do you follow? Do you follow? So look
Yes,
at that.
sir.
We say LAC1. Wala na tayo, we don't have a left and right anymore. Okay, so this is much easier. So let me close. Let me erase this everything. No. So it's much easier. So you see, as time went by, computers became simpler and simpler, and they become easier to program. Nowadays, we have a different style because we program in using compilers and translators, so it's much easier. Okay, in those days you have to program and to do the looping manually. Okay, so we have LAC1. What do you mean? Load accumulator, no? LAC. Okay, that's what it means. Let's look at that. It's in the PDP1 programming handbook. No, it's in the handbook. Because in the earlier version of PDP1, there's no mul, but later in the PDP7, there's a mul and a div. Okay, which has the same function as that of the IAS. Do you follow? No? Okay. Okay. So LAC, load accumulator. So now the accumulator becomes what? 4. Sorry, 4. Okay. And then we say sub 2. That's how do we do it. We omit the M. Okay. Do you follow? 2 is the address. When you say LAC1, 1 is the address. Okay. So this becomes 4 minus 1. Right? Because 2 is the decrement. Okay. So the accumulator becomes 3. Take note, this is no bottom-up loop. You follow? But you can also write it down in top-down version. Okay? They follow? Because we have another equivalent for the jump plus. The equivalent for CF is SZA. They follow? SZA. We'll find that out. No? We'll find that out anyway. Sub 2, so the accumulator becomes 3, and we say DAC3. What do you mean by DAC3? It means deposit accumulator, no? It's like the equivalent of store, no? Deposit accumulator. So which means the accumulator is now in 3. Do you follow? Do you follow? And then now we have again LAC1.
Yes, sir.
So pareho lang, di ba? It's just like Python and C#. They have changed the vocabulary, but the logic is the same, okay? LAC1, so this is 4, right? 4, and then we say mul 3. So the content of 3 is what? The content of M3 is 3. The content of the accumulator is 4, right? The content of the accumulator is 4. 3. 3 means M of 3. Do you follow? So this is now 3. So 4 times 3, this becomes 12. Do you follow? And then DAC1, which means deposit accumulator. So the result is deposited here. They have to change, no? They have to change the vocabulary to avoid being, copying. But during those times, copying is not an issue, no? I will explain why. It was not an issue because, there's a story behind, no? So LA's deposit 1, so this becomes 12, and LAC3, the accumulator becomes 3, and then we have sub 2. So 3 minus 1, this becomes 2. Okay. DAC3, so the 2 we deposit here, no? Do you follow? And then we say SZA, skip on 0 accumulator. Do you follow? Which means that if the accumulator is 0, we will skip 14, we will go to 15, and 15 is our halt. So strange, no? Skip will only skip 1, but it will already allow us to do some looping. So will we skip the accumulator here? Will we skip here? No, because the accumulator is not 0. So instead we will jump to 7. Dito. Do you follow? We'll jump to 7, which is the head of our tail. It's the same, no? It has a more complex skip because it's longer, but it's much easier to program because there's no left and right. Okay? So now we go to 7 because we jumped 7. LAC, what's our accumulator? Our accumulator here is 2. We have 12. We have, this is 1, this is 2. You follow? Okay. So the same story, no? LAC1, which means load accumulator from 1. 1 is 12, so the accumulator becomes 12. Okay. Mul 3. So M3, this now becomes 12 times 2 because the accumulator is, rather M3 is 2, so this becomes 24. And we say deposit accumulator, so we deposit 2. The accumulator to 1, so this becomes 24. Okay. Unlock 3, which means we will now load the accumulator with what is in value in memory 3, which is 2. Sub 2, this becomes 2 minus 1 because the M of 2 is 1. So this becomes 1. They follow. And deposit 3, so which means we will deposit the 1 here. They follow? They follow? Suppose the question is skip on 0 accumulator. Will we skip? No, because the accumulator is not 0. So therefore, we will have an accumulator of 1. This is 24. This is 1. This is 1. Okay. We'll go back to 7. So LAC1, load accumulator. From 1, this is 24. Anyway, 24, no? And then mul 3 is now 1. So this is 24 times 1. So this is 24. And deposit accumulator to 1, 24. And load accumulator, we follow, which will compute. So this will now become 1. 1 minus 1 is 0 because we have sub 1. So now deposit accumulator to 3. So the accumulator is now here, 0. Now skip on 0. What will happen? Is the accumulator 0? JMP7, no? JMP7 means jump to memory address 7. Yes, that's correct. No? Kung sa IAS, jump, whole word na jump. Sa PDP, JMP. Okay? So memory address, no? Memory address na ito, no? Memory address ito, jump. These are memory addresses. Yes, memory address. And we have, the good thing about the PDP-1 is we have a linear address, no? We don't say jump to the left, jump to the right. It's completely linear. So it's a much easier computer to ano. So now we have the correct answer, which is 24, because skip on 0 is the direct equivalent of CF. Do you follow? Do you follow? So you'd like to write this on a bottom top-down version. Yes, you can also do that, because in fact there's an equivalent of jump plus, no? There's an equivalent of jump plus. Okay. Skip if positive, no? Skip if negative is the opposite of skip is positive, no? You follow? Okay. Skip on plus accumulator. What do you mean by plus accumulator? This is an accumulator which is plus but not 0. Do you follow? Skip on minus accumulator. Skip if the accumulator is negative. Okay. Zero overflow means during a division or there's no remainder, no? And there are so many skips, no? But okay, obviously we can do any type of looping we like. We can do top down, we can do bottom up, because we have a lot of skips. Okay, I'm going to upload this now. Do you follow? This is not the one. Bottom up lang. I'm going to upload this. I think it's already there, no? Do you follow? So now we have an easier computer to program, because the memory words are the same. Uniform siya, whether it's uniform whether data or instructions. Okay? Do you follow? So the computers have improved at that time. So you have an assignment, no? Okay, the same. Compute the average. Okay, now using PDP-1. Okay. Any questions that's due on Monday? Okay, very easy. It's much easier now. Okay. So, however, no, in the IBM PC nowadays, there's so many jumps, no? So you will not have a problem of structuring your loop, whether bottom-up structure or top-down structure, because there are so many jumps, no? Unlike in the IAS and the analytical engine, there's only one type of conditional jump. Okay? So you now have a programming assignment for the PDP-1. Madali na lang ito, no? Write a program to compute the average of the first 3 numbers with loop and give a trace. Do you follow? This is due on August 16. Do we have a class on August 16? Diba Kadayawan? Isn't this Kadayawan week? Maybe for sure 21 is a holiday, but anyway, it's not declared yet. But anyway, we'll have a class on 16, no? If not declared, no? If it's declared, I will move the assignment. Okay. Any questions so far? No. Now you may ask, if you look at the chronology, no, why are so many computers invented and assembled? Isn't this copyright? Isn't there any copyright law during the time? Okay. There's a very strange story about this, no, because you look at the chronology, EDVAC and IAS were released at the same time. Do you follow?
Yes, sir.
EDVAC and IAS, but they are both stored program concepts from Jan van Neumann, which means there were two groups who were making computers during those times. No, there are two groups: the group of Eckert and Mockley in Penn State, and the group of Jan van Neumann in Princeton College. They were racing to produce the first stored program concept computer. Do you follow? And they declared that they both finished in 1952. Okay, so they're even. Okay, who first invented a stored program computer? But the stored program concept was credited to Jan van Neumann. And you may ask, what happened to IBM? Why is it producing a lot of machines? Look at that, no? In 1953, right after the release of IAS, no, IBM produced a computer very similar to IAS. Is this legal during the time? For nowadays, this should be you could be sued, no, for copyright laws here, for patent laws here, no. In 1953 to 1955, it made a lesser version of 701 that could compete with the UNIVAC, no, because the UNIVAC uses magnetic tapes, no. So IBM released 702 so that it could compete with UNIVAC. It's a much lesser, but they built 14. They didn't say how much they sold it, but millions ito during that time, no. And then right on the same year, no, IBM released 704. It's like the 701, but it uses magnetic core memory and can now store 80K. It used to be 4K only, no? And now uses or computes using floating point operations, which means it's now more accurate, no? It plays music. And they built 123 units, which they sold at $2 million per unit for 123. Imagine how much is that? That's equivalent to 200 plus millions, million dollars during that time. They made IBM very rich. IBM was a tech giant, and it wasn't paying any royalty to Van Neumann. Okay, so then 1954 to 1955, IBM 705 was released. No, this time it can accommodate 160K of magnetic drum. No, it was withdrawn from the market because it did not work. But the popular version was the 709, which was the improved version of the 704. No, it's now single precision floating point. No, so it's much lesser accuracy, but it now has floating point. It can now accommodate characters because it uses BCD, binary coded decimal, no, like our ASCII now. No, now it includes I/O channels, no, which means now it can be connected to different I/O ports like printers, no, tapes, basically tapes, no, printers, punch card readers, and writers. Now this was the first computer which used a high-level language called Fortran, which was invented by John Backus for IBM, no, IBM in 1956. John Backus was an engineer at IBM. No? So John Backus invented Fortran, formula translator. Do you follow? It's a crude basic, no? And then IBM first had competition during the late 1950s, 1960. The 7030, also known as a stretch, no? This is transistor version. This is a second generation computer, no? Second generation ito. The first generation were made of second ba o third? No, second kasi vacuum tubes. The first generations of computers were made of vacuum tubes. The second generation are made of transistors, no? At the same time, PDP released their first PDP-1 mini computer, which was very successful. They sold 53. Imagine, IBM only sold 19 for its first computer, and they were selling it very cheap, no? Way cheaper than IBM, and that's why they dominated the market. Okay, remember during 1960 when the 790 was released, no? 1959 first installed, IBM was selling it at 2.9 million only. Okay, but the PDP during that time never released a version of their own. However, by 1962, PDP released PDP-4, or rather DEC released PDP-4. It's also an 18-bit processor, no, of the PDP-1. Okay, it's a cheaper version. No, they built 35 and they sold it only for $65,000. It's still a lot, but compared to the 3 million, there's a big difference, no? And the PDPs are easier to program. Remember, the PDPs are easier to program because they have uniform instruction and data length, no? Now by 1960, no, IBM changed into a different platform, the S360, 1963. Now this no longer has, this is a uniform, no, uniform length na. IBM S360 is a uniform length machine, They've gone away with the left and the right of the IAS. Okay, this was sold. This was very expensive, no? But DEC also produced a PDP-5 at a 12-bit ancestor of the PDP-8. It's a smaller version, and they sold it very cheaply at 27,000. And they sold and built 1,000 of these. No, so they still earned 27 million. They follow. And then PDP-6 was built in 1964. Now these are now transistorized, no? Transistorized, I think, pagka 65, microcomputer na, 1965. Do you follow? That's the third generation of computers, ICs na. Do you follow? By 1964, PDP built, rather DEC built PDP-6, a big computer, no? They built 23 for MIT, and they sold it for $300,000, no? 36-bit, which means it's a mainframe, no? It's like the IBM PC. By 1965, DEC released the PDP-7 ICs na ito, no? They built 120, 18-bit pa rin. Is this 18-bit, and they sold it for $72,000. No? PDP-8, which was a very popular version, no? 18,500, no? Very cheap, and they built and sold 50,000 of which. By 1966, no? These are now ICs, no? The time of ICs, third generation of computers. PDP built a mini computer, 36-bit upgrade of the PDP-7. 35,000 lang naman, no? And PDP-10, during those times, IBM released different versions of the S360. Still $1 million, no? But I think it has gone cheaper because it now has competition. Okay. 1969, the mini computer, PDP-12 relative to PDP-8. PDP-8 was a very popular version because it's very cheap. No? It's the mini computer equivalent of the PDP-8. It's called the PDP-12. In 1970, no, this is a very important part, no, because PDP-11 was released. It was the one and only 16-bit DEC. Do you follow? They built 600,000 and sold each at 10,900. No, it's very cheap. No, I think it's the cheapest DEC that was ever produced. No, during that time because it's a 16-bit machine. It's almost like the IBM PC nowadays. No? $10,000. No? And then by 1970, microcomputers na. Okay. This is the age of microcomputers, 1970s. No? Do you follow? Okay. PDP-16, it's not. It's only a module for the PDP-11 and 15. Do you follow? And by 1976, no, there came a different scenario. No? Steve Wozniak and Steve Jobs invented a PC, the personal computer called Apple. No, it's sold very cheaply at $666, lesser than $1,000. No, IBM was still producing S360, but facing the competition of microcomputers, no, IBM released the IBM PC by 1981. In response to the Apple revolution, okay, so that they can also sell computers very cheaply. IBM personal computer, the personal computer you have nowadays, and now sadly, no, during the 1980s, DEC experienced a decline. Why? Because they did not produce personal computers. Do you follow? So that eventually, no, DEC was purchased by Compaq in 1998, and HP bought Compaq in 2001. Okay. That's the story. Now there's a very significant controversy here. Where did all the royalty go? What happened to John von Neumann? Did he earn anything from the stored program concept? Anyone? Do you know the story here? Do you know the story here? What happened?
Sir.
Huh? What happened to John von Neumann? He invented the concept and somebody's selling it for him. In fact, DEC and IBM became very rich. No? Yumaman sila ng yumaman. They didn't give anything to John von Neumann. Let's try to find out, no? Kasi this is what happened, no? During 1946, no? It was the time when John von Neumann developed the stored program concept. There were patent issues with the ENIAC because Presper and uh, Presper Eckert and Moakley filed for a patent. What is a patent? A patent is like a copyright, no? Which means that you own the technology and you have the sole rights to manufacture the same machine. All those who do not have the patent will have to get permission from the patent owner, and the patent owner will charge a royalty for the income, for the, of course, intellectual property, right? So during 1946, no, Presper Eckert and then filed for a patent for ENIAC. At the same time, they also included the patent for the stored program concept. Do you follow? You may ask, why did they include the stored program concept with the ENIAC when in fact ENIAC is not a stored program computer? Do you follow? Because during the time, they were racing to produce the EDVAC. Do you follow? Do you follow? They were
Yes, sir.
producing to produce the EDVAC. And then, before they were able to produce the EDVAC, John von Neumann made a report, an official report, and published it, the first draft of a report on EDVAC. Now, the first draft actually detailed the design of the stored program concept, but the author of the document is John von Neumann. But the manufacturer of EDVAC is Presper, Eckert, and Moakley, which means that during the time, no, Eckert and Moakley and von Neumann were working together, but they split up for any reason. Do you follow? So nowadays, John von Neumann is accredited to be the author of the stored program concept because he was the author of the first draft report on the EDVAC, which was released on 1940, after the war, no? So the first draft report outlined, no, the characteristic of the stored program concept. No? Do you follow? Do you follow? No? Okay. Now, however, when they filed a patent, Eckert and Moakley did not get the patent because there was the draft report on EDVAC, okay, prohibited them from getting the patent because it was John von Neumann's authorship. Do you follow? Do you follow? So in 1947, their patent for the from the no from the stored program concept was not approved. Okay, do you follow? So, however, in 1947, they applied for the broad and ENIAC patent, which means they no longer applied for the stored program concept. They just applied for the patent so that they could produce EDVAC. But but John von Neumann did not make any claim anymore for the stored program concept. Why? Because there are issues, no? There's a controversy behind. In 1956, no, Sperry Rand or Remington Rand bought Eckert and Moakley, and then Sperry Rand already is an affiliate of IBM. They were not paying royalties because IBM was already had exchange deals, no, with Sperry Rand. Now, in October 19, 1973, the patent was ruled invalid, such that no, all patent rights were cancelled from ENIAC, which means that they could no longer claim any royalty. Why was it cancelled? Okay, why was it cancelled? Because an evidence was obtained by a lawyer, okay, that the design of the ENIAC, a lot of the design of ENIAC was patterned from John Atanasov's report of 1940. Now remember, John Atanasov invented the ABC computer. Atanasov Berry computer, Iowa State University. So there was a plagiarism, there was an issue of because many of the concepts applied by by Presper Eckert and Mockley in the ENIAC and EDVAC were borrowed from key ideas of the design of the ABC computer. And then a court ruling was done, no? Sperry Rand was sued, no? For the violation. Sperry Rand was sued. Here's the and they were, here's the actual the actual verdict, no? By a circuit court. No? Honeywell versus Sperry Rand. Honeywell later, by the way, became the branch with Atanasov, no? Atanasov, no? Okay. So they were interviewed. This is what happened. This is actually what happened. So they were, no. It was during 1941. 1937 was the invention of the ABC computer, just before the war. 1938, it's an hour, no, 1936 or 1937. Okay. During that time, okay, Mockley spent some time as a guest at Atanasov's home in somewhere in Wisconsin, no? Iowa State kasi, no? Iowa State, yes. Spent from June 13 to June 18. And he spent uncounted hours discussing with Atanasov Berry computer. He was just talking about the computer and the computer theory with John Atanasov and Clifford Berry. After 4 days, Atanasov went to his office in the physics building and observed that Atanasov computing 1 days. He accompanied Atanasov, which means that Mockley was given a chance to look at the actual computer. He had seen the demonstrations of the operations, no, of the ABC computer and engaged in manipulation, which means he tried to operate the machine himself. And then he was given a 35-page manuscript to read the design of the Atanasov Berry computer, cover to cover. Remember that Mockley was also a math professor in Penn State, so he was able to read this. Okay. Okay. Now, right after that, upon going home, no, Penn State University, John Mockley did a crash course on computer electronics at the University of Pennsylvania because he's a mathematician, not a physicist. Unlike Atanasov and Berry, they were physicists, so they knew a lot of electronics. So he had a crash course. He studied overnight, no, on electronics. By August 15, 1941, he wrote a comprehensive memorandum between analog computers and pulse devices, which were the important ideas in the Atanasov's 30-page manuscript on the ABC. Now, on 1941, he wrote Atanasov suggesting that he would develop a computer. That computer was already ENIAC because ENIAC was started in 1943. Do you follow? And when the trial ended in 1971, no, Judge Larson is a circuit judge. I don't know where it is. No, declared unequivocally, no, that the ENIAC ideas were derived from Atanasov's invention. Okay, and thereby canceling the patent to Sperry Rand, no, which was already owned, no, the patent for ENIAC and EDVAC during that time. Okay, so did you follow? No. So this controversy made IBM and DEC very rich because they can now make computers, no, although it came later in the 1973s, freely without violating any patent rights. Do you follow? Any questions so far? So sad story, no? It's a very sad story, no? That, yeah, ENIAC was not an original invention. Okay, ENIAC and EDVAC were not. However, no, the stored program concept is still original because ABC is not. It already contains design on binary computing, but it did not detail any regarding the stored program concept. Okay, any questions so far? Okay, so you pass your assignment. Next meeting we will start with a new topic. Ano na ba tayo? Okay, new topic na tayo, no? We'll look at the generations of computers. We will look at the microcomputers, no? This is the 4th generation. Ito na yung sina Steve Wozniak, no, 1973, but formally started in 1971. And Steve Jobs, okay? Is the same ABC that owns Google, sir? No. No. Hindi na, iba na yan, no? ABC stands for Atanasoff Berry Computer. Okay. Ang ABC kasi is an umbrella organization created by Google so that it can spin away from Google, no? Because Google has a lot of ventures, no? Aside from YouTube, no? AI and so on and so forth. ABC stands for Atanasoff Berry Computer during the 1936. Let us look at that, or 37. Si Atanasoff Berry pala ang original inventor of an electronic computer. And I'd like you to look at the video, no, on how he invented, because this is already a very important, a very important invention, the ABC computer. Okay. Do we have that? There's a video on the ABC computer. So anyway, the computing technology has moved on, no? Nowadays, no, Intel is the dominant, the dominant source of technology, no? Okay. I'd like you to look at the ABC computer, no? How it works, because it's very much like I'll put up the, no, I'll connect the source later, no? Any questions so far? Okay. Next meeting will, now I've told you that we are going to have a formative test, right? Of all the topics of history of computing. We may do that last week of August na lang, na, so that you will have the third week as review. I can give you a sample test, no? Okay. So ito na lang naman eh. I think we can finish this in 1 or 2 or 3 meetings. So. Okay. The different generations of computers. Okay. And then the history of microcomputers, IBM PC, and the is there Apple here? Sorry, no. 1970s na ito, no. So the time of your parents. Okay. And then the yeah, fourth generation, yes, microcomputers. Nowadays, microcomputers pa rin, no? And then we look at the complete history of IBM PC. There should be 2 parts, okay? Wala siguro yung isa, no? I look for that, no? But anyway, the part 1 and the part 2 are connected. You can look at the part 2 anyway, anytime you like. And then history of Microsoft Windows, Bill Gates, no? And sino kasama niya dito? Paul Allen, Bill Gates, and tatlo ito sila, no? And then the brief history of the internet, how it came about. Okay. And then WWW, World Wide Web. And then that will be enough, no? That will be all for this chunk, no? Computing technology. Any questions so far? No? Bakit wala? I look up the the second part of the history of the IBM PC. And then in normal classes, no, we will go into the second grading. The second grading is like, but pandemic tayo ngayon, but anyway, we'll still follow the same, the same sequence. We will have Boolean logic, binary numbers, and Boolean logic, because we are going to study architecture, no, computer architecture, and we know that nowadays, no, computers are binary, so we need to study Boolean arithmetic, arithmetic on binary numbers, and Boolean algebra, no, Boolean algebra. Okay, and then before we look at the structure of the CPU, the ALU, no, because we have discussed them already, but we know how, but we don't know how they work. Ito nasobrahan na ito, no. I'll delete this. But ayaw. This is a duplication. The components of a computer system dapat marunong. Okay, and so on and so forth. Any questions so far? I'll upload this recording. Any questions?
Excuse me po, sir.
Yes.
Sir, sorry po. Kanina na-late ako sa attendance kasi yung Zoom ko palagi nag-connect po.
Okay, okay. Maningo.
Opo.
Who else? Who else did we miss?
Ako po, sir.
Is this Kanakan?
Kanakan din, sir. Thank you.
Anyone else?
Ako din, sir.
Is that, you know, who's that?
Kalyo, sir.
Kalyo, okay. Anyone else?
Dumandan po, sir.
Dumandan. Si Labrador, wala na gini pag-asa, no? Labrador and Lumapay. Okay, we just put them here. Placer. Last year, I had a student who just came back again during the formative test. Okay. We'll find that out, no? In the formative test. Okay. Any questions so far? So your assignment, no? Next week, PDP 1, the average, no? Of the first three numbers. Okay. So thank you very much. No? We have about 10 minutes, but we will not introduce a new topic. Okay. Thank you very much for coming, everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.